This is Spencer Riggs with Design Department, and this is another example of engineering triumphs and blunders. Today we're going over the Camaro that never was, an 80s research project known only as GM80. So recently I found myself in an automotive bind, and through a series of circumstances found myself owning an unexpectedly cool car, a 1993 Z28 Camaro. Now, obviously, as a devout car guy, I was thrilled. As an engineer, though, I was curious as to the history of what has become affectionately known as the Catfish Camaros made between 93 and 2002. Now, the story of the fourth gen was a lot more than I had originally thought. It was filled with top-level fumbles, internal limitations, and massive technological overreach. This story is underreported and requires a lot of backstory in order to make any sense of it at all. So let's get into it. The time is the neon generation. The place is Detroit. The trouble is the hyper-competitive Japanese auto industry turned superpower by virtue of the oil crisis of the 70s. For the first time in its history, American auto manufacturers were under restrictions for fuel economy and environmental preservation, and this created challenges for which the big three had no answer. Japan, by contrast, had been facing fuel supply shortages since World War II, and as such were already light years ahead of development for this particular issue. Their cars were already smaller, more reliable, and well established in America by the late 70s. And even after lobbying with Reagan to limit Japanese vehicle importation in 1980, the auto unions were still driving costs on American cars, and fuel prices were still on the rise. By 85, the domestic consequences of not having imported Japanese cars became politically and financially untenable, leading to the lift of those restrictions. Now, although Reagan had bought them time, U.S. autos were still struggling to generate a fleet of vehicles that was anything like competitive independently, and all of them had hedged their bets through foreign partnerships to produce Japanese cars in America. These relationships were born out of necessity to keep plants open and advance their understanding of this new front-wheel drive efficiency that had been so key to Japanese dominance. Ford and Mazda, Chrysler and Mitsubishi, GM, and Suzuki. Now, most of the big three's vehicles had been converted to front-wheel drive variants with varying levels of aid from their Japanese partnerships throughout the 80s. Front-wheel drive allowed cars to be drastically lighter, smaller, cheaper to produce, and with smaller engines. And even sports cars were changing to mirror this new Japanese model. And this is where the GM80 begins. It was a newborn effort to make the next generation of GM's Camaro and Firebird conform to this new standard. The GM80 was to be lighter through use of composite panels and front-wheel drive design, more fuel efficient via use of either a straight 4 or a V6, and would potentially include all-wheel drive. It was a purely domestic-founded effort to work within the Japanese wheelhouse using the latest technologies. They tried extruded aluminum, composite, and tubular chassis throughout the testing cycle, all of which failed crash tests. The new sheet-molded composite panels were both heavier and more expensive than initially anticipated, and the quad-4 V6 was too powerful for any existing GM transaxle and had to be down-tuned to make less torque than the current generation of Camaros and Firebirds, with a substantial increase in weight. And by its cancellation in 87, GM had spent nearly $1 billion in developing the GM80. And there's some countering information as to which came first, but at the same time Chevy was trying to make a front-wheel drive Camaro, Ford was doing the same with the Mustang, leveraging its partnership with Mazda. Documents were leaked about this plan, and the public outcry was so intense that this new Mustang quickly became its own badge, the Probe, to maintain the spirit of the rear-wheel drive performance vehicle. In some of my research, this very public flogging of Ford is attributed to convincing the leadership at GM to shutter the GM80 and go back to a more traditional rear-wheel drive style. But regardless of the why, public sentiment pushed both Ford and GM past their original 1990 release date for their new pony cars, with Chevy releasing the Gen 4 Camaro in 93 and Ford releasing the SN95 Mustang in 94. And it's worth noting that as a result of this extremely compressed design cycle, both manufacturers were forced to compromise using components that were already developed for other projects. And despite the delays and the failure of the GM80, much of the body research was utilized in creating the Gen 4 Camaro. And this on top of a heavily modified but proven third generation chassis, and the now iconic LT1 Corvette engine would give the Camaro a huge advantage that would lead them to being the premier American manufacturer for performance vehicles, a legacy that they have held to this day, depending on who you talk to. And there's, like I said, a lot of backstory and a lot to digest here. Honestly, I wasn't sure if I should classify this story as a triumph, a blunder, or just typical automotive industry convolution. My takeaway from all of this is that you can't be afraid to go your own way. Trying to recreate someone else's success will inevitably cost more than just making your own. As product design engineers, of course, we look at predicate design and compare those to where our project needs to go to some degree, and we also limit ourselves to a certain scope to operate within to control cascading changes. In the end, Chevy made the right call the hard way. All the time they had spent trying to be someone else, they could have been developing their own technologies to make them more competitive, which is exactly the strategy that they have adopted ever since. So I'd love to hear your thoughts on the GM80 in the comments below, or what personal takeaways you have from this story. Check back next Tuesday for another episode of Engineering Triumphs and Blunders, or check out our page to see our other series, An Engineered Approach.